This is SpaceTime, Series 23, Episode 111. Coming up on SpaceTime, the Neutron Star collision that's still producing X-rays 3 years later, a record-setting flight to the International Space Station, and the space station's crew have found the cause of an air leak on the orbiting outpost, but they haven't been able to fix it, at least not yet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers are still detecting X-rays being emitted from a location where two neutron stars collided 3 years ago. The findings, reported in the Journal of the Monthly Notices of the Royal Astronomical Society, are rewriting science's understanding of these cataclysmic events. The study's providing astronomers with the most complete start-to-finish observations ever undertaken of a neutron star merger. The cosmic collision, catalogued as GW170817, was initially detected by the LIGO and Virgo gravitational wave observatories, and telescopes around the world were quickly pointed in that direction, observing electromagnetic radiation including gamma rays and optical light emitted from the explosion. And since that day, astronomers have been continuously monitoring the subsequent radiation emissions, providing the most complete picture ever undertaken of such an event. Previous models had predicted that the X-ray emissions would have stopped by now, but the new observations showed that current models of neutron stars and compact body collisions must be missing some important information. The study's lead author, Eleanor Troja from the University of Maryland and NASA's Goddard Space Flight Center, says science is entering a new phase in its understanding of neutron stars. She says she really doesn't know what to expect from this point forward. That's because all previous models were predicting no X-rays. And yet 1,000 days after the collision event, they're still being detected. It may take years to finally answer what's going on, and these new observations are opening the door to many possibilities. GW170817 is the first and only time so far that astronomers have been able to observe electromagnetic radiation associated with a gravitational wave event. All other gravitational waves observed to date originated from events too weak and too far away for the radiation to be detected from Earth. Either that or they came from black holes which don't emit radiation, other that is of the long hypothesized Hawking radiation, which would be far too faint to be detected anyway. Seconds after GW170817 was detected, scientists recorded the initial jet of energy known as a gamma-ray burst. Then the slower kilonova appeared, a cloud of gas bursting forth behind the initial jet. Light from this kilonova lasted about 3 weeks and then gradually faded. Meanwhile, 9 days after the gravity wave was first detected, telescopes detected something they'd not seen before: X-rays. Models based on known astrophysics predicted that as the initial jet or gamma-ray burst from the neutron star collision moved through interstellar space, it would have created its own shock wave which would have emitted X-rays, radio waves and visible light. This is known as the afterglow. But such an afterglow had never been observed before. In this case, the afterglow peaked around 160 days after the gravitational waves were detected and then rapidly faded away. But the X-rays remained. They were last observed by NASA's Chandra X-ray Observatory some 2.5 years after GW170817 was first detected. The new research has already suggested a couple of possible explanations for these long-lived X-ray emissions. One possibility is that these X-rays represent a completely new feature of the collision's afterglow, and the dynamics of a gamma-ray burst are somehow different than what was expected. Troja says having a collision close enough to be visible opens a window into the whole process which astronomers rarely have access to. It may be there are physical processes which haven't been included in the models because they're not relevant in the earlier stages that scientists are more familiar with when the jets form. Another possibility is that the kilonova and the expanding gas cloud behind the initial jet of radiation may have created their own shock wave that's taking longer to reach the Earth. Because they saw the kilonova, they know there was a gas cloud there, and the X-rays from its shock wave may be the cause. But the authors admit they still need more data to understand if that is what they're seeing. If it is, it could give science a new tool, a new signature of these events which astronomers haven't recognized before. And that could help researchers find neutron star collisions in previous records of X-ray radiation. Of course, there is a third possibility. The The general assumption has been that these two neutron stars collided and produced a stellar mass black hole. But maybe something was left behind after the collision, perhaps the remnant of an X-ray emitting neutron star. But much more analysis will be needed before researchers can finally confirm exactly where these lingering X-rays came from. This is SpaceTime. Still to come, a record-setting flight to the International Space Station, and the space station's crew have located the source of an air leak that's been venting atmosphere into space for more than a year now, but they've been unable to fix it, at least so far. Details on that and a lot more still to come on SpaceTime. This episode of SpaceTime is brought to you by LastPass, simplifying your online life. Now, if you're anything like me, one of the biggest frustrations and time-consuming parts of going online anywhere is trying to remember and then use all those login details and passwords that you've built up over the years. And again, like me, you probably already have hundreds of them. Of course, on the other hand, you could just be like a lot of other people out there and simply use one password for everything, and that's not a particularly secure idea. But I guess it could be worse. You could be one of those people that use 1, 2, 3, 4, 5 or A, B, C, D, E, or worst of all, you could use password as your password. And with the internet getting more and more dangerous, now really is the time to do something about that. And the good news is there's a great solution out there. It's called LastPass Password Manager. And with it, suddenly all those security hassles are gone. And believe me, the relief really is unbelievable. Not to mention the time it saves you. And it's so convenient having everything stored in the one manageable dashboard. If you sign up for LastPass, you'll be joining some 25.6 million fellow users around the world and more than 70,000 businesses. Now, you've got to admit, that's a lot of trust with one of the most important aspects of online life. And the good news is, all this peace of mind is really affordable. If you want, you can simply sign up for the free service and leave it at that. Or for even more features, get the premium package, which is $4.50 a month. There are family and enterprise plans available as well. Plus, LastPass works across all devices and even suggests super secure passwords for you to use. So, why not put your passwords into autopilot and reduce the stress? You can check out LastPass at spacetimewithstuartgary.com/LastPass. That way, you'll be helping to support our show. So sign up and use it for free at spacetimewithstuartgary.com/LastPass and simplify your life. And like always, you'll find the link details in the show notes and on our website. That's spacetimewithstuartgary.com/LastPass. And now, it's back to the show.
This is SpaceTime with Stuart Gary.
The Expedition 64 crew have safely arrived aboard the International Space Station following a record-breaking two-orbit fast rendezvous flight aboard their Russian Soyuz MS-17 spacecraft. Most flights to the space station take about 2.5 days. But over the last few years, Russia's been perfecting various types of fast rendezvous flights. They initially began conducting flights taking just 6 hours to reach the space station. It's all in the timing of the launch compared to where the space station is in orbit. But on this latest mission, the crew docked to the orbiting outpost just 3 hours and 3 minutes after launching from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan.
The space station's flying directly over the Baikonur Cosmodrome in the launch pad. At the time of launch, the station will be 339 miles above the Soyuz as it leaves the pad. There's the first umbilical tower separating from the booster.
Launch.
Second umbilical now separating.
Ignition.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Intermediate. Main. Lift.
And lift off. Kate Rubin, Sergei Ryzhikov, and Sergei Kuznetsov now on their way to the International Space Station, the latest in a chain that spans almost 20 years of continuous human presence in space.
Their Soyuz capsule docked with the space station's Razvet module as the orbiting outpost was flying at some 28,000 kilometers per hour above the Mediterranean Sea. During Expedition 64, the crew will grow by 4 new members, with the arrival of Crew 1 aboard the SpaceX Crew Dragon capsule on the first operational commercial mission to the space station. It means the United States can once again launch humans into space from American soil. That's something they've not been able to do since the retirement of the Space Shuttle fleet in 2011. Dragon Crew 1 is slated for launch in November. Before they arrive, the existing Expedition 63 crew on station will return to Earth aboard their Soyuz MS-17 spacecraft. This mission comes just days ahead of celebrations marking the 20th anniversary of uninterrupted human presence in space. In its 20 years of operation, the space station's played host to some 241 people from 19 countries, including Australia. And more than 3,000 scientific research projects have been undertaken in the space station's unique microgravity environment. Meanwhile, the Expedition 63 crew have finally found the leak, which has been venting atmosphere into space from the orbiting outpost for more than a year now. However, while they've located the leak to a tiny crack, just 0.6 to 0.8 millimeters in size, in the Russian Zvezda module's intermediate transfer chamber, they've been unable to repair it. It seems like all good do-it-yourselfers, their first attempt involved using some adhesive tape. Is there anything duct tape won't do? Well, apparently the answer is yes. All attempts to plug the leak with the tape have so far failed. Russian Federal Space Agency mission managers in Moscow say pressure in the compartment has declined by 17 millimeters of mercury, down to 715 millimeters. The leak was first detected back in September 2019. And by August 2020, the rate of leakage had increased fivefold, from 270 grams to 1.4 kilograms of air a day. Now that might sound like a lot, but according to mission managers, it doesn't pose a risk to the crew on station at the moment. Unfortunately, Zvezda is the main module on the Russian side of the space station. It houses key life support equipment, and it provides half of the space station's oxygen and drinking water. It also contains living quarters for the 2 Russian crew members, including their sleeping accommodation, dining facilities, a refrigerator, a freezer, and their bathroom. Mind you, this isn't the first time crew members on the station have had to trace down leaks. Back in August 2018, they discovered a leak caused by a 2mm hole that had been drilled into the hull of a Russian Soyuz spacecraft, which was docked to the space station at the time. Although Russia's refusing to explain how the hole got there, the general consensus is that poor workmanship during the manufacture of the Soyuz spacecraft led to the hole being drilled there in the first place. And then a bad patch-up job to try and cover up the mistake made matters worse when it suddenly failed while the spacecraft was docked to the space station. The crew eventually patched that hole using an epoxy resin. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has confirmed the first case of COVID-19 reinfection in the United States. It's the 5th case of reinfection reported worldwide and indicates that exposure to the virus does not translate into guaranteed total immunity. The case, reported in the Lancet Medical Journal, was of a 25-year-old man who was infected with 2 distinct COVID-19 variants within a 48-day time frame while testing negative between the infections. The second infection was also more severe, resulting in hospitalization with oxygen support. The results indicate the need for further research into reinfection and the need for people to continue taking precautions to prevent infection, even if they've already been infected. So far, some 39 million people have been infected and over 1 million killed by the COVID-19 coronavirus in the 11 months since it first originated in Wuhan, China. A comprehensive global study of nitrous oxide, the 3rd most important greenhouse gas, has found that human-induced emissions have increased by 30% over the past 4 decades. The findings, reported in the journal Nature, exceed some of the highest projected emission scenarios, further underscoring the urgency to mitigate nitrous oxide emissions. And the dominant source of human-induced nitrous oxide emissions? Well, it's in the use of nitrogen fertilizers in gardening and agriculture. A new study warns that blood pressure treatments has been associated with double the rate of cognitive decline in older people. A report in the Journal of Gerontology has found blood pressure readings above 140 and left untreated will significantly worsen cognitive decline in older people. However, research by the University of New South Wales found that systolic blood pressure lower than 120 and treated with antihypertensive medications could also increase cognitive decline. Conservationists at Aussie Ark have reintroduced Tasmanian Devils into the wild of the Australian mainland for the first time in an estimated 3,000 years. 11 Tasmanian Devils were released into a 4 square kilometre wildlife sanctuary at the Barrington Tops National Park in the New South Wales Hunter region. Some 26 Tassie Devils will ultimately be released this year, with 20 more planned for release next year. Each animal is fitted with its own radio collar, allowing scientists to keep track of them and see how they're interacting with other wildlife in the sanctuary. For the past decade, Aussie Ark has been steadily building up their Tassie Devil populations, which have been decimated by a deadly facial tumour disease in their native Tasmania, where some 90% of the devil population has now been wiped out. Tassie Devils being released on Australia's mainland are all disease-free. Well, the big news in the tech world right now has got to be the release of the new Apple iPhone 12. With the details, we're joined by Alex Zaharov-Reutt from ITWire.com.
Hi, Stuart. Yes, well, there are 4 brand new iPhones. All of them have 5G. There was some conjecture that perhaps one of them might not have had 5G, but no, they've all got 5G. And the small one, the iPhone 12 mini, a lot of people have been asking this for a while because they wanted a phone that was sort of smaller in size, similar in size to the iPhone SE, the one from 2016 that had the iPhone 6S internals inside. And when Apple launched the iPhone SE 2020, which was basically the same size as the iPhone 6, 7, or 8, people said, oh, well, where's the one that's basically slightly smaller than that, but with a bigger screen because the screen goes edge to edge? And that's what the iPhone 12 mini is, with a 5.4-inch screen. And it's billed as the smallest, lightest, and thinnest 5G phone on the planet. Now, those in America will be able to get iPhones that you can't get anywhere else. These are iPhones that have the sub-6 5G spectrum, which is similar to the sort of spectrum being used for 4G, and also the millimeter wave spectrum, which in the US is, from memory, 38 gigahertz and 29 gigahertz. Now, in Australia, the millimeter wave 5G bandwidth will be 26 gigahertz. So we probably have to wait until iPhone 13 and the rest of the world as well before we will get iPhones that have both the sub-6 5G and the millimeter wave 5G. The millimeter wave 5G can deliver information a lot faster than the sub-6 5G, but you need to be much closer to the base station because there can be a lot of interference, even just from thick glass. So in one sense, it doesn't really matter that the rest of the world doesn't have the millimeter wave 5G because they don't have the towers in place. The spectrum hasn't been auctioned yet, certainly hasn't been auctioned in Australia. But in the States, Verizon, one of the big phone companies over there, was on stage with Apple, and they were proudly announcing it. And so this is a genuine improvement with the iPhones. But look, they've got better cameras. The cameras can let in more light, bigger sensors. They can do Dolby Vision on the Pro series with Dolby Vision recording and 4K editing. You can do all of that on the phone itself. The night mode is now on all of the different cameras. It only used to be on the main camera before. The screen, it's now called a ceramic shield screen, and it's using a transparent ceramic crystal sort of lattice over the top of the screen, and that is meant to improve the screen's strength by 4 times compared with last year's model. And of course, every year the screen has gotten better with different forms of Gorilla Glass. But this new screen is supposed to be much more impervious to cracking, but obviously I would still always make sure to get a screen protector and some sort of case. And on the back, the cases can now be magnetic. Apple has made its own Magsafe Charger. It still has the lightning port underneath. A lot of people thought it might go to USB-C. But the Magsafe Charger that works with Apple's own charging system and with those of other companies like Belkin who make third-party compatible chargers that are endorsed by Apple, this magnetic charging system not only ensures that the phone is placed correctly onto the charger, so you don't have a sort of a misaligned magnetic positioning that would mean a lower voltage, but instead of the 7.5 watt charge, the Magsafe chargers can do 15 watt. So you can still use QI charging pads for 7.5 watt, but if you want the faster one, of course, you'll have to buy something new. But, there are definite benefits. You can have these magnetic cases. You can have little credit card holders on the back. You can have these magnetic vent attachments that go into your car so you can position the phone quite easily and in the car and move it around and use it as a GPS map. So, there's some changes in that regard. It's got flat edges like it was rumored.
That's very old school, but isn't it?
Well, it was actually with the 4, the 5, the 5S, and the SE. And also it's on the new iPad Pro. So the 6 was the first one that had the rounded edges. And some people complained that it was a bit slipperier in the hand. And so they've sort of gone back to the past. And if you have a look on the right-hand side of the case, there's this sort of strange-looking section which is shaded in a sort of different color, and that actually is a window to allow the 5G signal to come into the phone. Otherwise, the metal around the phone would have blocked the signal. So they've thought of all of those sorts of things. But, one thing they've been criticized for is not including headphones and not including a charger in the box. Now, apparently in France, they have to include the headphones. I was reading the story. But for the rest of the world, they're not including headphones or the charger. They say a lot of people already have chargers and they already have the various headphones from previous models. Now, if you do get a USB-C charger, you can charge at 20 watts. Normally it's 18 watts, but the new one can do up to 20 watts. So people who've got existing USB-C chargers will probably need to get an even faster one. But at 18 watts, you can recharge the phone 70% of its battery capacity within 30 minutes.
Can I still charge it through my computer like I do now?
You still can, but most USB ports will only give 5 watts, so it'll be a slower charge, but it will still charge. You can use whatever charger you want as long as it can, as long as you can plug in a cable that has lightning on the end that goes into the bottom of the phone. But the iPhones will now come with, instead of the end of the lightning cable being USB-A, which is the sort of rectangular, plug that plugs into most standard computers, they'll now come with a USB-C cable as standard. And if you plug it into a computer that's got USB-C or you have the correct charger, it'll charge much faster. So, look, there's a lot of good stuff with these new iPhones. The iPhone 12 and the 12 Pro are already on sale in terms of pre-ordering, and they'll be available in stores and at retail from Friday, the 23rd of October. Now, the 12 Pro Max, which is the one that a lot of people are going to want, and the 12 Mini, which a lot of people will also want, the two opposite sizes, they will be available to pre-order from Saturday, the 7th of November, and they'll be in stores beginning Friday, the 13th of November. Interesting date, Friday the 13th, but that's what it is. That's right. And then the other thing they launched was a HomePod Mini, much smaller HomePod, $99 in the US, $149 in Australia. This takes a larger HomePod Mini, makes it smaller to compete with Google Home and Amazon Echo. It's got a more intelligent Siri chip inside. It's very loud. It looks like, and it works very closely with your iPhone and iPad. You can see things on the screen. So, Apple is really wanting to push HomePod, and the HomePod Mini should be a great way of doing just that.
And that's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.